Our next speaker is Dr. Michael Cahn, who is Irrigation and Water Resource Advisor for UC Cooperative Extension on the Central Coast, which is also nicknamed the salad bowl to the world. He's been with UC Extension, well, since 1995, a long time. His research and extension activities are focused in the areas of irrigation technology, water management of vegetable and horticultural crops, protection of groundwater quality and food safety. And importantly, he has led the development of CropManage, a really innovative online decision support tool for water and nutrient management of vegetables since 2011. Nice operational system, and it's more recently been adapted for berry, tree, vineyard, and forage crops. So welcome, Michael.
Okay, good afternoon. So I should also have Lee's name up there and Forrest Melton's, because we've been working together for probably a decade, right? Yeah, as Lee said, I work in the Salinas Valley on the Central Coast, and I would say 9 months of the year, all the vegetables in the country come from that region. And we also export to Canada, Mexico, Asia from there. So those are the top vegetables by value, and we produce about 74% of the lettuce. And just Monterey County, the vegetables are worth about $3 billion, and our sales annually in Monterey County are about $4.7 billion. So, but we have large farms, and we have some very small farms there too. And then we have lots of water issues. We don't have any water that's imported. All the water that is used for irrigation is groundwater. And we have to manage our aquifers there. And we do have seawater intrusion from the Pacific Ocean. And through the groundwater regulations now, they're trying to figure out how to sustainably manage the groundwater aquifers there. Also, because we have intensive vegetable production with multiple crops per season, we have nitrate contamination of our groundwater, and that's a big issue. So we have water quality issues, and we have water quantity issues. And so growers are under stricter and stricter regulations for nitrogen management, and they're going to have to get to certain targets in the use of nitrogen fertilizer, and to make up for the reduced amounts of nitrogen fertilizers, they have to start really accounting for all sources of nitrogen that are available to their crops. There's often residual mineral nitrogen in the soil. I mentioned the irrigation water is often full of nitrate, and they need to take that into account, and the residues that mineralize from the crops that are not completely harvested. We take lettuce, but there's residue behind that's incorporated, and that adds a lot of nitrogen to the soil. And they have to really match the fertilizer applications with the uptake rate of these crops that they're growing. So much more intensive management, I would say, of fertilizer. But also, they've got to get the water management right, because nitrate is very mobile, and we're growing shallow crops. You know, the root zone is maybe 2 feet in depth, and so you over irrigate for a few extra hours, and you've just lost a lot of your nitrogen. And so that was the reason we started developing a tool growers could use in the field on their smartphones, or they can use it in their office on tablet computers to give them decision support on both nitrogen and irrigation. So that's where CropManage comes in. And what it does is provides really site-specific recommendations based on their weather, their soil types, the crop they're growing, the development stage of the crop. And we started out doing this for lettuce, but as you see, we've expanded it to other crops. And it also is based on the research that us in Cooperative Extension have been doing for years. But now it takes that research and makes it available, and customizable for the grower's conditions, right? And the other aspect to it is growers can keep records of what they're actually doing, because often they don't know on a specific field how much nitrogen they put on. They just know at the end of the season, for all the lettuce they grew on that ranch, this is about the amount of nitrogen they applied. So we've worked with a lot of vegetable crops, and then we expanded into berries, which we also grow a lot on the Central Coast. And then my colleagues in the Central Valley said, can you do this in trees and forage crops? So we expanded CropManage into the Central Valley for those commodities. And it's really become a platform that's very cooperative. You know, if there's a researcher that's interested in getting their model on CropManage for a specific commodity, you know, we've worked with them and we've got them on the platform. So what drives the irrigation scheduling component is weather-based irrigation scheduling, estimating ET. And for a lot of the specialty crop commodities, figuring out what the crop coefficient is difficult, right? So what we learned was we could really base this on, just like the satellites do, on fractional cover. And if we could model fractional cover for a lot of these commodities, they're grown very consistently every season, then we could put those models into this software. And so that's what we did. We took photos, NDVI photos from a lot of commercial fields, and developed these curves for the crop coefficients. But a crop coefficient isn't enough for the person in the field. We need to take crop ET and get it to hours of runtime. And so we make that very easy, because when they set up their planting and CropManage, they put information such as the application uniformity, if they want to have a leaching fraction for salinity of the water, and the application rate of the system, then they can instantly get a recommendation of how long to irrigate. And just to show you sort of what it would look like, you know, you pick a date you want to irrigate, what type of irrigation system you're using, because sometimes we use sprinklers or drip on the same crop. They click, they get a recommendation in seconds, literally seconds. So that says about 4 hours. And if they want to see, well, why did it say 4 hours? They click on the recommendation summary, and they can see, okay, the average reference ET was 0.19 inches a day. The average crop coefficient is a little bit above 1. There's the distribution uniformity. 2 days since the last irrigation. We know the application rate of the system, so we give them that recommendation. So CropManage has to pull in reference ET. And so we started with the CIMIS weather network in California. There's 150 stations. And there's an option, you know, if you have 2 stations near you, you can use those 2 stations sequentially or average them together. There's also a spatial CIMIS option that we have in California. And then for future dates, we usually utilize historical ETO. Now, our partners in Arizona were interested in participating, so we now have the ASMET system in there. And we have some partners in Hawaii that are trying to service the Pacific Islands. So we have some hobo stations that they set up in Hawaii and in Guam and American Samoa. So, you know, we've been collaborating with different institutions on this, and now we're working on integrating OpenET, reference ET data into CropManage through the GridMet. But for a long time, we've been working with SIMS, and what we were interested in is the fractional cover that SIMS can provide. And I have to say, you know, over the years, I've noticed SIMS has gotten better and better. And I think that it shows you the same thing you'll find with OpenET is we work on these models, they'll get better. And this is an example. This is the canopy development or fractional fractional cover curve for, I believe it's a lettuce crop. And the blue line is our model. The black symbols come in from SIMS. And if you can see those green squares, that's ground truth data. And you can see they all line up very nicely. And so what a grower can do is we got the model there, but you can adjust the curve based on the SIMS data that comes in and customize the fractional cover for your specific crop. And we often are working with growers with CropManage, demonstrating how they can improve their irrigation management. So we like to put out sensors to monitor and verify, right? Trust but verify. So we have a flow meter. This is on a vineyard that we can monitor every irrigation, and that goes into a data logger that's connected by a cell phone modem, and in the cloud it can go into CropManage. And we can do that with soil moisture sensors too. And what is also nice about this platform is we've been doing lots of trials, especially with Lee Johnson, to make sure our algorithms are accurate. And what the grower is really concerned about is not necessarily putting an eddy covariance tower out there. They want to see if you follow the recommendation, you maximize yield and quality. So we have often done these trials where we do different percentages of the recommended amount of water and make sure that 100% what's recommended by CropManage is maximizing yield. So in terms of integrating CropManage with OpenET, our objectives are really to be able to expand the geographical range serviced by CropManage by integrating OpenET data from the API and really seamlessly import reference ET, eventually actual ET estimates, and the fractional cover, because that's sort of migrating from the SIM site over into OpenET. So our current activities are we're updating CropManage to bring in that reference ET data, the gridded data from, what is it called, GridMet, right? And also, we are working with Lee and Forrest to assist in collecting actual eddy covariance data in these vegetable fields to verify the accuracy of OpenET. We have come across a few roadblocks in retrieving reference ET data from the API. So the way we use this ET data is it's not going to be a geographical zone all confined. So we have to do lots of different calls because we're going to be in different places, and when a user wants that data is going to be at a different time than another user. So we get some problems with limits on how many queries we can do. Also, we need the data now. We can't wait for 3 days. And right now, what OpenET does is puts an estimate in for the last 3 days and then updates it later. So then we have to do some more calls. We do come up against this monthly limit for API calls. And one problem is we've noticed some of the ETO values will be 0 over a large geographical area, and that's from the GridMet system. So there's all of these things we have to work out before this is really useful in real time. And we're using, I just have to say, we're using OpenET in a much different way than many of the water managers may be doing. So eventually, we want to bring in the ETA data into CropManage so a grower could see what's recommended in ideal situation and then compare that with what's really happening out there. And we're working on developing some simple calculators that users can use so they don't have to use the full package of CropManage. And this would be for calculating their seasonal ET. And they could use CropManage for doing that, but we would like to bring in the ETA from OpenET to do that. And then we're just going to continue field testing CropManage irrigation recommendations and compare that with what OpenET reference ET estimates are. So that's sort of what we're trying to do, and I'll just summarize that, CropManage is a tool that really can be used in the field to guide irrigation and fertilizer management. It's a irrigation decision support is really based on getting good ET data. If we don't have good ET data, we don't give good decision support. And it is definitely scalable to other regions and other types of crops. And then we're just currently working on trying to get it integrated with OpenET. So with that, I'd be happy to answer any questions.
Any questions? They're recording this, so they ask that any questioners speak into the microphone here. So let me pass this over your way.
Thanks for the presentation. It's really great to see it. I'm wondering, you mentioned a few things that seem like they would need to be done if you were to expand it into a new geography, like getting reference ET data and crop-specific models. But I'm curious if you could elaborate on, if I knew somebody who wants a tool like this and wanted to work with you, like what type of commitment would be required, or what would need to be developed in order to make it work in a new spot?
Yeah, thanks for that question. So there's sort of two components to that, or maybe three. We have to make sure, of course, we have reference ET data for the region they want to work on, and it's very reliable. The second part is, for the commodities they're growing there, we have to make sure we have the models in there. And they may want to participate in developing those models and then add those into CropManage. And we are not wed to any specific ET model. We can make adjustments, and we have had to do that as we moved from vegetables to berries to tree crops to vineyards. So we have to make those very different models. And then the third part is really extending this to the growers, being committed. So I call it the CropManage franchise. If you want that in this tool in your region, you really have to do all three parts to it and be committed to really extending it to the growers, because why build it if they don't know about it? Yeah.
Thanks so much, Michael. We should probably move on from there. I would say that Cooperative Extension has given us some really good feedback on the API, and they're helping us to make it better. And I think that some of the recent pushes to the software reflect that, and will continue to make things work more and more smoothly vis-a-vis their system.